Hello there, I'm Thomas Hatsios, German America pilot flying the Boeing 787-900 night flight. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 14 for an ILS localizer landing. So now I'm in the cockpit with the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments, displays and the functions of the Boeing 787-900Z aircraft. I'm going to start with the primary flight display. That displays the airspeed indicator, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude selected from the autopilot and flight director system panel, the target altitude selected from the autopilot flight director system panel, and also the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in 10,000 feet per minute, all the steepness of the trigonometric counts decrease can climb and descend. We have also the altitude indicator with the artificial horizon, the pitch ladder decrease and the bank angle decrease. The ILS localizer, we have the ILS localizer system, the instrument landing system that receives the radio frequency transmitters from its runway will be used for takeoff and for landing. That has the radio antennas that transmit the unique radio tune frequency for its runway and magnetic north pole heading. We're going to use 136 degrees for the runway 14 in Zurich International Airport, and its frequency receiver we're gonna tune. Also we have so it's gonna display, it's gonna receive from the onboard antennas of the aircraft, the horizontal localizer and the vertical glide slope, so we can align with the runway for takeoff and for landing using the horizontal localizer and the vertical glide slope. You can see also the ILS localizer in the primary flight display. We have the flight director for manual guidance of the aircraft and the autopilot cross for automatic guidance of the aircraft. We have also the flight mode annunciator with the autopilot and the autothrottle vertical navigation mode. We have also the HSI that displays the horizontal situation indicator with the decorated flight plan display. You can see the one waypoint by another. So we're gonna create a flight plan. You will see the stars, the waypoints, which will connect the legs of the waypoint of the flight plan. Also in the navigation display, we have the navigation display that displays the horizontal and vertical profile of the aircraft as it flies. You can see terrain and weather reflections from the weather radar displayed with red, green and amber or yellow color, and also the lakes, rivers and sea with the blue. So we can see also the 4-letter account name of each airport. So we have our own airport displayed in the navigation display with a 4-letter name. Also we can see from the GPS receivers our position, latitude and longitude, coordinates position, and also we can see the runways I'm going to use for takeoff and for landing, the taxiways, and also the runway length and heading. So we have the geographic North Pole and magnetic North Pole and the magnetic variation depending on where we are on the world. So we have also we have the voice stations, ADF and the NDBs, which are navigation aids, the navaids. Also we have the waypoints which are horizontal vertical navigation fixes and altitude and airspeed constraints. The aircraft is going to have to fly through some waypoints during its flight. So you will see we're gonna select using the flight management computer over here, and it's gonna be displayed in the navigation display and also in the HSI when we create the flight plan of the aircraft for this flight or any flight. So also you're gonna see other things, other systems, the outside view, the flight controls. So also the navigation display, you can see the vertical and horizontal profile of the aircraft as it flies. We can see also other aircraft that fly around our own aircraft using the transponder, the screen, ADC transmitter receiver transmits our frequencies to other aircraft and the air traffic control and receives from other aircraft. You can calculate using its computer and the radio frequency difference. You can calculate the other aircraft location and distance, the bearing towards our aircraft. Also, you can calculate the altitude difference from our aircraft in hundreds and thousands of feet if it is higher or below, above or below. You can also calculate whether they climb or descend with respect to our aircraft, and also you can calculate the velocity closer in between our aircraft and the other aircraft. It will give us a warning from the TICA system, the traffic collision advisory system. You can see the diamond shape of the other aircraft displayed in the navigation display. Also we have other things to see. We're gonna see the flight controls here. I'm having the side stick. I can control the flight controls of the Boeing 787. So I'm having the Airbus identical side stick. And you can see the movement back and forth. I can climb and ascend the aircraft using the pitch axis, the elevator for climb descent. Also I can make left and right turns using the control wheel or the control the longitudinal axis. Also the rudder pedals, you can use the rudder pedals to make left and right turns, directional control using the rudder or the vertical stabilizer. So you will see one by one all the systems and the flight controls. You can see from the outside view over here. I can control the flight controls from the outside, so we can climb, descend, use the rudder to make left and right turns, ailerons and spoilers. So I will explain in a couple of minutes how we're gonna do. Also we have the nose wheel steering, the control of the nose wheels. So I will explain you all these things. So we have here, you can see in the primary flight display, you can see we have the airspeed indicated, the airspeed tape over here. You can see the airspeed selected from the autopilot flight director system panel. It's the same 200 knots. Also the airspeed guidance here, the heading guidance, and the altitude guidance. The altitude selected from the autopilot flight director system panel. So you can see here also in the primary flight display and the HSI. So we have the airspeed tape. You will see the airspeed increase when we go for takeoff. In flight we have the airspeed selected from the autopilot flight director system panel, the altitude selected from the autopilot flight director system panel, 10,000 feet, 200 knots, the barometric altitude above the sea level right now 1,430 feet, and the vertical rate of climb descent of the aircraft, the vertical speed indicator. You will see this needle moving up when we climb, like 500, 1,000, 1,500, 2,000, 3,000, 6,000 feet per minute, or with descent. And also you can see the pitch ladder, the pitch attitude of the aircraft in degrees. So we have 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 for pitch up or pitch down. Also the bank roll of the aircraft in flight. You will see we make like 5, 10, 20, 30, 45 degrees over here of turns. So you can see also we have the flight director here, the crossbars, the takeoff, go around, the flight mode annunciator. So we have the thrust levers for takeoff over here, the thrust control. You will see we can the takeoff go around mode. Also we have the HSI here. We have also the radio altitude. You can see above the ground level it can display up to 2,500 feet. Right now it shows -2. You can see also the HSI here is the horizontal situation indicator. You can see the heading selected 360 degrees as displays here. Select heading 0 or magnetic GPS, ADF left and ADF right. Now the frequency from the ADFs over here. So you can see also we have the barometric pressure over here at the outside atmosphere. The barometric altitude is set using the barometric pressure. You can see also the wings level of the aircraft here, this indication, also the turn here, and also the turn coordinator. So we're gonna have also the barometric pressure over here, 29.92 inches of mercury is set, and the radio minimums for landing. So we can set using the FS panel over here, the barometric pressure for the barometric altitude over here, as you can see in this panel over the glare sheet or the autopilot flight director system panel. So we have inches of mercury or hectopascals. Also the radio minimum, flight path vector meters, also the plan and the range. This is for the displays, the radar, traffic and terrain. on the navigation display over here. So we set right now 39.92 inches of mercury and 200 minimum. So 29.92 inches of mercury equals 1013 hectopascals HPA, as you can read here the barrel set. So this will give us a barometric altitude for this airport and runway elevation 1430 feet. So this is controlled from the air data computer. Over here you can see the air data computer, heading reference, left and right IRS inertial reference system, controls the GPS receiver, the laser gyroscopes that align the aircraft in coordinates, and also the pitot tubes, pitot dynamic, pitot static for the airspeed and the altitude. Over here are controlled from this air data computer, and they display in all screens. Also the magnetic north pole, geographic north pole, GPS receivers, and alignment of the aircraft. Laser, also the gyroscopic processing, deceleration, the altitude indicator. So the air data are received from this air data computer. So we can set it here the plan, map, menu, range, weather, radar, traffic, and terrain on the display. Also accept, cancel, reject some warnings. You can see here the range is 80 nautical miles for the map, like here. You can increase or decrease the range displayed in the map or the plan from this screen. So we will display right now 80 nautical miles, the magnetic north pole. Some airports here, you can see the Germany over here, this side the France over here. So you can see the Switzerland down here, maybe very left. So we have also the altitude of the aircraft as it flies, the altitude selected from the autopilot flight director system panel, the terrain in front of it. So you can see the vertical display over here, the engines indications we're gonna talk about in a couple of minutes. Also the autopilot flight director system panel, you can see here we have the autopilot engage and disengage. So it's the flight director, engage and disengage, the from left and right, engage, disengage, LNAV and VNAV from the flight management computer, flight level change, climb continuous, and also the airspeed in nautical miles, 200 nautical miles per hour right now selected. Also the heading guidance over here, bank angle and heading, hold, heading on track, indicated airspeed or Mach speed, and select Mach. Also vertical speed here, or flight path angle, you will see later. We have also the altitude in thousands or hundreds of feet, and auto we can hold world localizer and also approach for the auto land here, as you can see, for the auto land function of the Boeing 787. Also the airports in higher distance over here, the other side, what it displays the same things. So we can see also, I'm gonna talk to you about the engines indications also are displayed from the FAREX. So you can see the left and the right engine indication. So we have the N1, which is the low speed starter and sub low pressure compressor and turbine of the turbofan, which is engine over here. The exhaust gas temperature pricing, the takeoff limit 99.2% and the idle thrust right now to 80.7, the red, green, yellow limits. The exhaust gas temperature pricing, the N2, which is the high speed starter and sub high pressure compressor and turbine of the turbofan engine, 78.1%. The fuel flow per engine per hour, 1000 kilograms or thousands of pounds per engine per hour. Oil pressure, oil temperature, oil quantity over here, and the vibration of the N2 stage of the engine. You can see also gross weight for takeoff and total fuel on board, the fuel temperature and saturated air temperature. Some other indications here also. So we have the cabin pressurization, that means pressurizer from the N2 stage, the 59th stage of the compressors. Cabin pressurization system here. When we climb the aircraft will pressurize. With the pressurized distance, you can see cabin altitude, rate of climb descent, differential pressure, and landing altitude. So when we climb like 45,000 feet, the cabin altitude will be like 8,000 feet maximum, 7 or 6,000 if we fly lower. And also the differential pressure is gonna be 7.8 pounds per square inch when we pressurize the cabin, 7.8 or 8. Landing altitude manual and forward and aft outflow valves for depressurize the cabin of the aircraft. So you can use these switches over here for pressurization, manual or automatic control, and the outflow valves open and close. Select the landing altitude. You can see here is the pressurization from the engines. That also supplies the air conditioning and ventilation over here, oxygen regulation in flight, and also the wing and engine on the ice, hydraulic fluid tanks pressurization, and some other systems. So you can see also so we have here I'm gonna start showing you the outside view of the aircraft. So I'm talking to you about most of the display views. Later also the flight management computer here we're gonna use to create a flight plan. Also use the mouse pad here. You can see also some other things, the thrust levers over here. So when we move the thrust levers forward, we command the engines over here. So we have electronic engine control over here for the engines that controls the EC computer that controls the fatics, also the auto start of the engines. So the fatics control the full authority digital electronic control computers. One is called forensic gearbox, dual channel redundancy. One channel face, the other takes all controls, and displays all the engine data using the upper and lower ACAS and the indication for the system display or the multifunction display for the Boeing 787. So we have the N1, which is the low speed starter sub low pressure compressor and turbine of the turbofan, which is the engine with exhaust gas fan, which brains in the end, which is high speed starter sub and high pressure compressor and turbine of the turbofan, with the engine. The fuel flow brains per 1,000 kilograms times pounds of pressure or temperature quantity and vibration within the speeds of the engine. They also control the outflow air pressurizer from the fifth and ninth stage of the engines and the bypasser. We need for hydraulic fluid tanks pressurization, air conditioning and ventilation, oxygen regulation in flight, and also cabin pressurization of the cabin of the aircraft as the flight with the and also for wing and engine on the ice. So all the hydraulic fluid tanks systems that we move using the flight controls are actuated hydraulically. The landing gear extend and retract, parking brakes, thrust reverse for the engines. Need hydraulic, we need pressurizer from the engines to work like this. As you see the elevator moving up and down, we need hydraulic power, which also pressurized from the engines, leader, and from the hydraulic pumps, and engine driving and electric driving that we have. The rudder, also ailerons, spoilers, flaps, speed brakes, so nozzle steering. So we have a lot of things. So also, as I'm gonna talk later about the fatics, I have to show you now the flight controls. I will show you a bit more the flight controls of the aircraft of the Boeing 787 right now. I will show you also the horizontal trim stabilizer of the elevator. Also, we have the automatic trim of the aircraft, and this is a fly-by-wire aircraft. It has its flight control computers. I will show you right now. You can control all the flight controls in flight in normal, alternate, and direct mode, like in the Airbus aircraft. You have the acceleration for left and right turns, 2.8 G, maximum of 67 degrees, with the side stick input, and you can climb descent about 1.5 G and minus half G descent, and also plus 30 degrees or minus 30 degrees. So it's quite similar. You have the flight control computers over here in the auto position. primary flight control computers, auto or disconnect, and you have the normal alternate and direct low of the flight control computers. So when in flight, you move the flight control of the aircraft, like the yoke for climb and descent, to deflect the elevator. On spoilers, you give a command to the flight control computers to make calculations about the flight control deflections or the rudder, like in the Airbus aircraft. Also, you have the automatic trimming. So when you fly, you move the side stick in the Airbus for climb and descent. On the Boeing, you move the yoke, you move the elevator, climb and descent. You have also the horizontal trim stabilizer. And the Boeing aircraft, you have the suites in the Boeing 787. In other aircraft like in the Airbus or the Boeing 737, you have the trim wheel. So you can see here the trim suites that we have for the horizontal trim stabilizer of the aircraft over here. So you can see here we have the elevator trim, left click down, right click, as it says, right click up, left click down, right click over here up, and the airspeed, the flap speed. So you climb, you move the elevator up, the trim suites over here, and when you descend, you move the trim suites down. Elevator trim, left click down, right click up, the flaps speed, and also you have the autopilot disengage switch over here. The head-up declutter over here. So when you move the elevator trim like this switch, you trim the elevator up, and you pitch, you give an aerodynamic effect to pitch the nose of the aircraft up. That helps you to move the aircraft up and down using the flight controls like this, as you can see. Also, when you need to pitch the nose down, you trim the elevator down, so you have either aerodynamic effect, elevator trim, left click down, right click, as you can read, elevator trim. So we can see the elevator trim position in decrease over here, 4.5 right now in green band instead for takeoff. The flaps also in the rudder trim position, as you can read. So mainly interested for the rudder, the horizontal stabilizer trim. So we have also the alternate. So this was the normal channel. We have the alternate flight control computers channel over here for the pitch trim of the Boeing 787. So we use this nose up to pitch the elevator up, and to trim the elevator up and pitch the nose up as we fly, and pitch the nose down or trim the elevator down as we fly. So this is the alternate channel of the trim, and we have the stabilizer cut off over here, as you can see. So you can see again elevator trim over here, up and down. Also the parking brakes off like this. The mouse pad I will talk to you in a couple of minutes. So this is the elevator alternate trimming, and we have also the automatic trim from the flight control computers over here, as I told you. So when we have flying manually, or we have the autopilot flight director system panel connected with the LNAV, the VNAV, or the auto throttle or other modes, we have the auto trim function for the horizontal stabilizer over here. So in auto trim function, if we have a failure of the hydraulic systems over here, either left or right, affects in flight, the flight control computer's function and the movement of the command of the flight control surfaces. You can see here flight control surfaces. We may have a malfunction of the horizontal trim stabilizer or auto trim function. So this is for all Boeing 737, Boeing 747, Boeing 757, Boeing 767, Boeing 777, and also Boeing 787 models. You open up this red guarded switch here from normal to cut off. So you cut off the horizontal stabilizer from the auto trim function, and you're still having the alternate trim, pitch trim over here for climb and descent like this. Alternate, and also the manual channel, the alternate channel, the manual channel trim over here. So you keep having this all the time for trimming. So you can see I'm having in the joystick this trim control over here for the flight controls of the aircraft of the Boeing 787 as we fly. So you can see also, I'm gonna show you now, also we have the flaps position, the speed brakes, the auxiliary flight controls. So I'm gonna show you now the outside view of the aircraft. I will talk to you about Newton's physics, aeronautical and aerospace engineering, and derive some principles we need to know for flying the aircraft, the Boeing 787 jet aircraft. So you will see how I'm using the flight controls of the aircraft, the side stick and the yoke, the side stick and the airbus of the yoke in the Boeing 787, the control wheel and the control column, also the rudder pedals. Also we have the nose wheel steering and the vertical rudders. So we have here, you can see the outside view of the aircraft. So you can see the wings of the aircraft hold the weight of the aircraft as we fly. Over here, the surface area of the wings. We have also the jet blast from the engines, the propulsion from the engines over here. The jet blast that moves the aircraft forward, these vectors. From physics, you can see the exhaust cone. We have the high pressure compressor and turbine, low pressure compressor and turbine, front fans, combustion chamber, and exhaust nozzle over here, the cone. So we have the thrust vectors from the engines. We have the mean aerodynamic chord in the wings, the Mach, which is 23% of the mean aerodynamic chord position, where the maximum aerodynamic lift occurs in the forward wings. Is also the position where the center of pressure is moving the top surface of the wings back and forth when we fly. Also where the stall will begin, the airflow becomes detached all the way back, so the wings will stall in flight. And we need to apply, we need to monitor here in the primary flight display all the time when flying to see that the aircraft is not stalled. So you can see the airspeed when flying. You can see a amber and red color indication just below the airspeed. This is the stall speed warning. So you need to advance the thrust levers forward when you are reaching a stall, and push the yoke down to avoid the aircraft wings from stalling, because it's the forward wings that may stall in flight. So you need also, you have the aerodynamic chord. We have the center fuel tanks over here, and the left wing tank and the right wing tank, the fuel of the aircraft over here. Where is the aerodynamic chord? And also where is the center of gravity of the aircraft is the yawing axis that transverses all this weight. So the yawing axis is doing this, it deflects the rudder right or left like this to steer the aircraft in the air. So this is the yawing axis, the vertical axis of this center of gravity. It also controls in the ground the nozzle steering. So we can use on the nozzle steering the ground 76 degrees left and right deflection from 0 to 45 nautical miles per hour. In takeoff we have the rudder aerodynamically effective, so it decreases automatically from the computers above 45 nautical miles per hour. In takeoff it decreases to 7.6 degrees because we have the rudder coming in, and then as we increase the takeoff speed to like 80 nautical miles per hour, it deactivates completely, and we have only the rudder aerodynamically effective for controlling the aircraft. So you can see we have the rudder pedals here for controlling the nose wheel steering of the aircraft. We have also the tiller for controlling the nose wheel steering, and also the rudder pedals simultaneously. In takeoff, then we have only the rudder, so we lose the nose wheel steering from it locks at zero deflection. We have only the rudder aerodynamically effective. So we have also from wingtip to wingtip, we have the lateral axis of the aircraft, which is the pitch axis. So in the Airbus aircraft is the elevators, is the side stick back and forth, as you can see. So you climb and you descend using the side stick like this. So this is the elevator axis. So we climb and we descend like this using the elevator. So this is the side stick back and forth in the Airbus is the yoke, the control column back and forth. And the Boeing is doing the same thing, same control, the elevator for climb and for descent, and also the elevator trim in the side stick right now. So this is very easy. This is the pitch axis, the yawing axis, the rudder pedals, and also we have one more axis over here. So you can see from nose to tail we have the longitudinal axis, which transverses all other axes. In the Airbus is the roll, side stick left and right. In the Boeing is the control wheel like this. So you have the control wheel to make left and right turns, the ailerons, spoilers and flaperons in the air. So you have all control axes together, full flight simultaneously. Flight controls you can apply one by one if you like. So this is side stick left and right, make left and right turns. Also the flight controls like this, left and right turns again. The rudder pedal also. So this is all flight controls also. Finishing the aerodynamics, you can see the bottom surface of the wings is more flat, and we have also the flaps extended, and also in takeoff we're going to be having a positive angle of attack. So using the Bernoulli fluids, the airflow moving much slower below the wings, so we have higher pressure, which pressurizes the aircraft weight and wings up into the air. Also you can see the top surface of the wings using Bernoulli fluids again, Newton's physics. The airflow is moving much faster because they are curved from the top above the wings, so we have lower air pressure, which pressurizes, sucks the aircraft's weight and wings up into the air. We have lower air pressure above the wings and higher pressure below the wings, mainly. So it depends on the altitude also of the aircraft and the flight conditions to have them like that. Also you can see we have a few more minutes. I will show you one more view of the flight controls of the Boeing 787. Then I'm going to talk to you about the flight management computer, how I'm going to create the flight plan. So you will see this nice view of the flight controls, and also the outside view of the thrust levers, also how we apply the thrust levers to control the engine's thrust of the Boeing 787 aircraft or the Airbus aircraft. So you can see we have this Logitech Extreme 3D, the side stick, which is identical to the Airbus. I have my computer also. You can see I'm having also the mouse pad here for this full setup like this. So I'm gonna show you now. I can use also this side view of the Boeing 787 cockpit and its flight controls. So you can see we can climb and we can descend like this. make right and left turns over here using the control wheel. Elevator, climb, descent. I hope you like this view of the Boeing 787. Also the engines, the thrust levers. You can see I'm using this side stick to control the engine's thrust, like that. So when apply like 60, 70, 80, 90, 100% or idle thrust, you'll see the movement of the thrust levers. So hope you like the view of the Boeing 787. As we fly later, you're gonna see full flight in the end part of the video. So stay with me until the end part. So you can climb, descend, make turns to the left and to the right. Also here you can climb, descend, make turns right, left, aileron spoilers, rudder pedal, vertical rudder, vertical stabilizer axle, and horizontal stabilizer, climb, descend, the elevator. So this full flight controls the elevator. Here you can see climb, descend. Ailerons and spoilers, left and right deflection, and the elevator control like this. So I'm gonna show you now the inside view. That was enough for the flight controls lesson. Now I'm going inside, show you the flight management computer. So I'm gonna use the flight management computer to input all the data of the aircraft for this flight. That includes the empty weight, plus the departure, plus the cargo, plus the fuel on board, where the fuel is stored in the left and the right wing in the center tank. We have 30% in the left and the right wing and 10% in the center tank. The flight management computer is going to calculate the center of gravity before takeoff and after takeoff and during the whole flight. We burn fuel, your center of gravity is recalculated every second. Also for takeoff, the center of gravity and the aerodynamic chord position, the Mach 33% of the aerodynamic chord position, horizontal trim stabilizer 4.25 degrees. We can take off like this. It's gonna make all calculations. So we're gonna have full thrust, full takeoff thrust power for takeoff like 99 or 100%. We're gonna set also the horizontal trim stabilizer to 4.25 degrees and have the flaps at 15 degrees. Also we're gonna select the takeoff runway, Lszh in Switzerland, runway 14. We're gonna set the runway length, the runway slope, the wind direction and speed, the parametric pressure, the density of the air and the temperature of the air. It's gonna give us the takeoff speed V1, we rotate and V2 like 130, 140 knots or 250 kilometers per hour approximately. We're gonna have the takeoff rotation 9 degrees or less, and I'm gonna insert also this the seats, the acceleration, the departure waypoints and fixes that include horizontal vertical navigation, fixes in altitude and speed constraints for the initial climb of the aircraft and departure. We're gonna have to climb to the cruise level at 25, 26, 37, 28, 29, 30,000 feet above the sea level. We're gonna cross through some waypoint, make some turns, then we're gonna descend back to the elevation of the airport like 6 or 7 thousand feet above the sea level. We're gonna have to be aligned with the stars, the southern terminal arrival waypoints and fixes, which are long and short final. The terminal approach waypoints for approach and landing of the aircraft. We're gonna be aligned with the runway heading of 136 degrees magnetic north pole heading. Also gonna use the Lszh localizer for the instrument landing system of the airport runway. Each runway has its own Lszh localizer, radio frequency, and antenna to transmit the radio frequency, and it's received from the aircraft on board. Antennas. It will display the localizer, horizontal localizer, and the vertical glide slope, so we can follow the flight path for approach and landing, both horizontal and localizer and vertical glide slope. From the receiver, so the Lszh localizer process is going to be having also an airspeed 160-170 knots or 270 kilometers an hour approximately for approach and landing, about 25-30 degrees of flaps extended, also a pitch attitude of 9 degrees or less, landing gear extended, and also we're going to be using thrust of 60 or 70% approximately for approach and landing. So we're going to be touching down with 9 degrees or less. So we're going to be having the full flight over here, full manual flight. You're going to see in the other part of the video after I'm going to set up the flight management computer and the engines start. So you're going to see now we have here this mouse pad I'm going to use to control and the keyboard functions over here for my computer for these instruments, the flight management computer. So we have this mouse pad here to control it in case you want. The keyboard also function, the index. So you can see here we have identity, position, performance, takeoff, approach, and unset status, flight plan, slotted track control, navigation data. Also you can set the screens over here using the mouse pad. So you'll see later how I'm gonna do also that. So I'm gonna show you this view of the aircraft cockpit, and we're going after. So you can see again the mouse pad, the thrust levers, the autopilot flight director system panel. So we set up the flight management computer over here, identity over here. You can see model Boeing 787, the GNX engine, the air rack cycle, position, Lszh airport international, and the alignment, inertial alignment. So go back to the index performance. You can see zero fuel weight plus fuel on board. We have the gross weight for takeoff, the reserve fuel, the cruise altitude, the cost index, fuel freezing temperature, and cruise center of gravity. So we set up the route first. Lszh Zurich International, back to Zurich International Airport. Copy paste over here. So you can copy paste. Lszh clear. Runway 14 over here for takeoff. Departures and arrivals, we can set departures over here, either runway 10, 14, 16, 2832. So we select runway 14, and the seasons are the instrument departures, Zurich to Alpha. So we have also the arrivals. Set the arrivals here. We can set either VOM 162834, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we set runway ILS 14, Trans Samity, Trans Negria 1 Alpha, the stars and the transition waypoint. So we have the legs, the route displayed with blue, not yet activated. So we have the first waypoint for takeoff, climb to the Zui, make turn, climb to the Nigria, descend over here, Aniki Zurich 701, approach, landing to the runway. So set zero fuel weight 322.7 thousand pounds plus fuel on board 33.3. We have 356.1, and the reserve fuel 5%. Gross cruising altitude, we're gonna fly to 25,000 or 7,000 meters approximately or higher. 100% cost index. Fuel freezing temperature is gonna freeze below 37 degrees. Cruising center of gravity. So we can press the execute button. It will activate the flight plan. So we have first waypoint 136 degrees, 2 nautical miles from the airport. This heading 250 knots and 1,900. We make left turn 1 nautical mile, 5 nautical miles, 6 nautical miles. The Zui heading 052 left turn 301 knots, 6,000 alpha. Keep climbing to the Nigria. Make left turn 07 126 nautical miles, 301 knots, flight level 32,000, 300, make a right turn here for Matic, 2 nautical miles, 320 knots, 11,800, Amiki, we keep heading 258, 6 nautical miles, 10,400, 190 knots, 9 nautical miles, Zurich, 276, heading 180, 7,000 Alpha, Zurich, 701, 6 nautical miles, 180, 6,000 Alpha, descend approach here, C114, 6 nautical miles, also make left turn here for approach for alignment of the runway, 170 knots, 4,000 Alpha, runway 148 nautical miles. So we have initialized here the flaps for takeoff, center of gravity and trim automatically 23% and 4.85. Takeoff speed V1, V-rotate and V2. So we have route, departure, arrival, alternate, VNAV, progress. We can set a holding flight, fix navigation radio, tune Lszh and voice if we need. So we go back, visual cockpit. You can see here we have this navigation display. You can see the flight plan over here displayed in the vertical, also terrain and also in the horizontal. So if we look a little bit closer, you see the data one by one, the waypoint, the purple line. You can see also the terrain, yellow, green and red, the terrain map. Also if we look even closer, you can see the runway we're gonna use for takeoff, the taxiway in front of us and the one beside us, the whole airport also. So you can see the taxiway in front and the one we're gonna use for takeoff here, just like from the outside. In the original you have in the GPS display, the terrain and navigation. Also you can see the plan over here. So we look a little bit further away, we're gonna have also some indications about navigation over here. Airports are further away over here. You can see France, Germany and Switzerland. So look closer. Also map centering over here. So we need to go very fast now for starting the engines. We have the left and the right IGZ, 100 to 200 volts for 100 Hz frequency. Start the APU, alternate current. We have the battery, primary flight control computers in the auto, heading reference, flight control surfaces over here, battery towing power F2 door over here, passenger oxygen, window heat, hydraulics, primary turbine over here. So we set off the primary demand, engine driving. We keep having the electric, so we set back to the on and then to the auto position. We have the wing and engine RDIs over here, and then auto position. Also we have the recorders, the cargo and APU fire over here, the electronic engine control for the engine, the auto start over here. You can start the engines later when you turn them off. Fuel jettison, get down some fuel, press this and select the nozzles and how much fuel to remain to make an emergency landing. Also fuel booster pumps, the cross feed valve. We can feed either engine with either pump or either tank. This is left and right wing and the center tank. Fuel booster pumps here on and off, and the balance the fuel. So we can use also the air conditioning pressurizer from the engines, air conditioning, pressurization, oxygen regulation in flight. We use all flow valves in the manual, climb, descend, and in the auto we need nothing to do. So this is all the overhead panel. I will show you now. It's here. Show you the displays very quickly. So we go back here, navigation display, also audio displays, systems display. So we have the systems displayed like this. So you can see we have the hydraulics, APU is running, oxygen and liquid cooling. Also here you can see the electrics, left and right IGZ, 130 to 200 volts for 100 Hz frequency. The APU is running, where the electric goes, load set, and also the batteries, main voltage and other rods, main and APU battery. So we have two batteries. We have the hydraulics over here, where the hydraulic fluid goes with systems used, sort of valves, left and right engine, C1 and C2 electric, and fuel press, hydraulic pressure 5100 psi in the quantity, of hydraulic fluid. Also you can see left and right wing, fuel tank, center tank. We have 11,000, 11,000 and 10,000, total 33,000. So we have the long high pressure fuel valves left and right engine, open and feed both engines from the center left and right wing. The APU is fed from left wing. This motor, the corrosive valve is off, but we turn it on, can feed either engine without powering the tank. You can also monitor the minimum fuel temperature here, below which the fuel will freeze in flight, minus 37 degrees, and minus 6 is the temperature right now of the fuel. So we recirculate automatically the fuel from the wing tanks and the center tank to the engines, and also the oil on the reprogram to heat it up. Pressurizer, the packs, also the doors are closed, the cabin can be pressurized. The gear, you can see the temperature of the brakes and the pressure of the tires. Flight controls over here, we can move the flight control, you can see the deflection, the tail also, the rudder trim, elevator trim. So this last part of the controls we need to know before make the engine start demonstration. Also you can see here we have FS display, also maintenance over here, systems, circuit breakers, again system checklist, normal menu, what to do before start, after takeoff, descent, approach and landing. So go back in the navigation display, we need to turn off the engines and restart them over here. You see an engine start demonstration. So turn off both fuel control to the off position. You will see what happens over here, fuel starvation. So we have also the amber indication. So we look outside. So we have no fuel now to the engines, and the engines are shutting down. So we need to start the auto start system very quickly. Here you will see the amber reconfiguration, switches, color, lights on. So we have over here pressurizer admitted from the APU, bleeder from the APU to the engines. So above 20%, can hear the roar. We have pressurizer right now, so we can let the fuel flow over here, both fuel control to the on position. So we have the auto start is kicking in, auto start on over here. So we have 29, 30, 38%, 39, 42, 47, 49, 50. So the engines are almost ready. Auto start 61 and running, as you can see. Both engines running. We can set flaps for takeoff, speed brakes up. Also the engines here, the autopilot, as you can see, engage, disengage over here, auto throttle left and right, flight director on and off, the LNAV and VNAV. So VNAV here, we can set the airspeed like 253, bank angle heading over here, we're gonna set the heading for takeoff 136. Degrees, the altitude, we're gonna fly 25,000 or higher. I'm gonna set 35,300, and the vertical speed, so 0. We can also descend and we can also climb, as you can see. So we set the plus sign, the slider we're gonna show us we can climb. So we are ready for takeoff. Parking brakes off over here. So advance the thrust levers and go. We take the clearance from the air traffic control and advance for takeoff. So we use the tiller here mainly for steering. You can see the runway is open for us, so we use again the tiller So we advance the thrust levers to full takeoff power. So we press the yoke down until 80 knots and align with the rudder pedals. So we have 90 knots, 100, 120, 130. So we have V1. We rotate over here, so we rotate like 9 degrees. It's 9 degrees up. So we have the positive rate of climb. Keep climbing over here. So we have the positive rate of climb, as you can see. Landing gear up over here. Just control up. You can see we can climbing. So we have all the air data over here. You can see we have the airspeed right now is 200 knots. The altitude we are 1,800, 900, 2,000 feet above the ground, but 3,600 above the sea. We climb with 5,000, 6,000, 5,000 feet per minute. The wind direction and speed right now, the pitch attitude of the aircraft, the stall speed. Also you can see the terrain, red, green and yellow indication over here. Also you can see the terrain below you. So this will show us the reflections from the terrain below us, this green wave. So you can see the aircraft is flying 3,000 feet above the ground below us over here. So we need to pay attention to the airspeed and the altitudes we fly. So see here you can see the outside view. We're gonna start turning right now the runway, the Switzerland here, the Swiss, the lakes and the Swiss Alps. So we're gonna start the turn now. So you can see we can leave the hands off from the side stick, no problem. The air data here we need to follow. So we align right now and see the outside view where we are located. So we have this beautiful view again from the Switzerland. Hope you like this beautiful view, the star sign, the galactic view of the aircraft, the Boeing 787. So you can see the whole of Switzerland here, the lakes, the Swiss Alps, the Germany over here, and the France on this side. It's going to be overflying. Over here, one area, as you can see. So hope you like the view of the aircraft, the cockpit over here. That's after takeoff. So the indications here we need to align with the air data here. So you can see again the airspeed, the stall speed with the amber and red indication here. So we need to avoid the stall. The climb rate over here, 2,900 feet. The wind direction 23 knots over here. In the next waypoint we have to follow the distance to the next waypoint over here. We have it here actually. In the this display also. The other side display, as you can see. So I'm gonna show you now, and we have like a couple more minutes to make turn for going back to the airport. for landing. So you can see here the flight plan that we follow is correct. Autopilot flight director, system panel, the other side. So we have one more minute. Galactic view over here. The France over here. My homeland, the Germany, in front of you. It's Bayern Munich and the Swiss Alps over here. So I hope you like this view. So we're gonna start the turn now. Going back to the airport. Very fast. So you can see we can leave the hands off from the flight controls as we turn, no problem. So this is the turn over here, also the attitude of the turn. So here we are turning. You can see again the beautiful view, the Germany, we ever find Germany over here. 20,000 feet and keep climbing. As you can see, the Boeing 787. The lakes, beautiful lakes, and the France. So we need to align with the flight plan again. Use a little bit right rudder to make more steep turn. And we're gonna start our descent in a couple of minutes. So we cross 21,000 feet over here. Keep climbing. So keep climbing over here. As you can see, we need to cross through these waypoints. So keep climbing, and we have the chemtrails in a couple of seconds. So here they are, the chemtrails, the frozen vapors from the exhaust of the engines, as you can see. You can see also a beautiful view of here, the galaxy. So I need to put it down a little bit. Galactic view also here. The lakes, you can see the France in this side. So we need to start the descent in a couple of minutes. So we are descending now. Speed brakes down a bit. So here we are descending. So keep descent. Gonna be overflying the airport now. Hope you like again the view of the cockpit from this altitude, from this descent over here now to approach for landing. So line the waypoints here, make a turn as we are descending, keep descending. So we're gonna start the turn now for approach and landing. We have a few more minutes left for approach and landing. So we start the turn now. You can see the turn, keep descending. So this is the turn. Use a little bit left rudder here for this descent. Increase the turn rate also. Make a more steep approach. So we need 3 more minutes approximately. We are almost aligned with the runway. A bit left, right now. More to the right. And we need a few more minutes for approach landing. Slowly gear down. So we need to be aligned with the runway heading over here. Make a turn. A bit more flaps over here. So you can see we have the Lszh localizer over here. We're approaching for landing using the Lszh localizer. So we have some side wind, some wind gusts over here. So we have a few more seconds. Wind gust, side wind, we'll use all flight controls. And also we need to start the flare in a couple of seconds. Allowing for the flare over here. So we're going to be flaring the aircraft, as you can see. flare for the touchdown of the aircraft. Beautiful flare, beautiful touchdown, and we have parking brakes over here set, and idle thrust and thrust reverse, as you can see, and we're slowing down the aircraft. So you can see we made a very beautiful landing over here. Also, thrust reverses over here, thrust reverse off,